let's go. 3, 2, 1.
Good afternoon, my name is Alex Taylor. Welcome to Power BI Lunch and Learn. Today we are live to do our series of 6 1-hour on-demand series. Today we have got 2 talks. First of all, we've got Lewis Holmes, who'll be doing a utilising Power Query and M-Code with financial reporting. And then afterwards, we'll have Sheb Rheman, who'll be doing a Power BI data modelling and creating a Star Schema from a flat file source. These sessions are recorded, so you can play them back at your own leisure, and we will be doing it for the next 6 Wednesdays. And if they prove successful, we'll be doing a series 2. A little bit of information, so people that are probably new to this is part of the Power BI user groups, which go on in Leeds and Manchester. I run the Manchester one and the Leeds one. The Manchester one's been going for 3 years. We've got over 2,000 plus members. We get 80 to 100 attendees face-to-face when we can do face-to-face meetups. We had 150 for our last webinar, and these run every last Thursday of the month. So we have actually got a session next Thursday. We're very popular, and the rates, you can see, are very good. A little bit of information about myself. I am a 16 years experienced recruiter, specialising in the BI and data space. I head up the BI and data analytics team for Waltz. So if you are in the market for a new role, whether it be contract or perm, please do get in touch. My details are below. But also, if you're a hiring manager who's looking to recruit someone, please do contact me. So today's agenda, as I said, after my little intro, we've got Lewis doing utilising Power Query, followed by Sheb, and then wrap up and close. Questions, if you have got questions for the panel of speakers today, please add them on the chat box. Please try not to be anonymous, otherwise we can struggle to locate who's asked what questions, so we can then publish them live. Little intro about Lewis. So I've known Lewis for the best part of 6 years, from his days at ISA and then at Betfred. He is a seasoned contractor specialising in the Microsoft stack, and he's got at least 3.5 years of Power BI experience. Sheb, I've known Sheb for the last 3 years. Sheb is a Power BI specialist. He is a trainer, he is an architect, and he's heavily involved with helping me with Power BI user groups in both Manchester and Leeds. He'll be happy to help out with any questions you have, and he's heavily involved with lots of different training courses up and down the country. So with that ado, I'll get Sheb to pass us over to Lewis.
Thank you very much, Alex. Hi everyone, hope you're well. I'm just going to pass over to Lewis in a second. And Lewis, you are live in 3, 2, 1.
Thank you, Sheb. Yeah, so as Alex said, my name is Lewis Holmes. I am a business intelligence contractor. I've been working with Power BI for the past 3 or 4 years. And before that, I've had a lot of experience predominantly on the Microsoft business intelligence stack. So today I'm going to talk you through a simple example of how to load some revenue data into your reports, load some target data, and then to kind of rephase that so they're in alignment, chart it up, and hopefully generate some nice dashboards that show you how you're comparing sort of against your target data. I'm going to assume you have some working knowledge of Power Query, Power BI, DAX, but there isn't anything too complicated within this. So I've already got a Power BI open. I've already imported a calendar table into this. Get out of the way. Yes, so I have my calendar table in already. So I'm just going to go ahead and load some sales data in. So I have a local SQL Server instance. So I'm just going to connect into that and pull up my sales data and load that into Power BI. We're going to use import mode for this. So now I have my sales table. If we jump onto the data view, you'll see that the sales table contains a few columns. You've got the sale ID, a product ID, the date, platform, and revenue. So in this example, we don't really care about the individual sales. We just care about a daily aggregation of the revenue. So this sale ID and product ID isn't really needed. And we've got lots of rows in here, so we can reduce the amount of data we're exposing to the model. So to do that, you just need to jump into Power Query, which on the remodeled interface is under Transform Data. Here we go. I'll just refresh my preview. Okay, So this is the data. So as I said, we're not interested in sale or product, so we can just right click and remove those. So we've removed a couple of columns, and now if we order this ascending, just so as an example, you'll see there are multiple sales per date, and we don't really need that. We're going to aggregate this up. So I'll remove the sorting because that'll hurt performance. But then if we click on group by, we can tell it under advanced to group by sales data in the platform, and we're going to sum up the revenue. Okay, so now we will have one row per date per instance of the platform. There are only two platforms this company has, this imaginary company. They have a channel for the website and a channel for the app. So now we have a total of the revenue, we have a sales date. I'm just going to rename the columns so they're a bit more consistent. So we've got date, platform, revenue. One important thing to check if you're coming from SQL Server is to always check the native query. So this is the query runs against SQL Server to load the data. If it's a SQL Server source, you can always right click and do view native query, and it shows you the code it's running against the database. In my opinion, it's always preferable to have the database do as much work as possible. So there are some operations, and I've gone out of that already. There are some operations that can't be pushed down to the database level. So if I just jump back in there, but fortunately in this instance, it can do all that, and you can see the query at each step. So if at any point this option is grayed out, you know you've done an operation that can't be pushed down to the underlying database. In my opinion, it's always better to try and push everything down to the database level, and to do that, I would generally follow a pattern. So I would remove any columns that aren't being used. I'll then apply any filters you want to apply by using the filters on these options. I would then sort out any data types that are incorrect, and then apply grouping, and then finally any calculated columns. It tends to be more complicated calculations that break the native query. So if you do that towards the end, you've got all the benefits beforehand of the grouping and the filtering and all the other operations. So there isn't too much to be said there, so I'll load that data into the model. So now we have a sales table. I'm just going to create a quick measure that gives us the revenue. So that's just going to be the sum of the revenue. And obviously I can't do that, so I'm going to call it revenue total. And I just need to check my relationship between the sales and the calendar table. So it's not automatically detected it, so I'll just drag that across. Jumping back onto the report view, I can now bring in the date from the calendar and then the revenue total. And we'll make this a chart. So now we can see the daily revenue, which is quite sporadic. I use a random number generator to get the sales, so that's kind of as I would expect. To get a year-to-date figure, there's a built-in function. So if you create a new measure, do revenue cumulative, and it's total year-to-date. And we're going to give it the measure I've already created, revenue total, and you just have to give it the date from the date table. There are some extra functions on there if you're not working on calendar years. So now we can bring this one into the chart, take away that, and now we've got pretty much a straight line showing the revenue year to date. It's gone flat here because obviously we don't have any sales into the future, and I'll show you how to get rid of that in a moment. The other side to this is the target data. So quite often, in my experience, there's a colleague in finance who provides you with an Excel file that looks something like this, where they've got by month how much revenue they want to generate per platform, which is fine. Quite often they're not targeted down to individual days. These targets in particular seem to have a little bit of a bump over the summer months and then kind of calm down over the winter. That could be just the seasonality of the business. Again, that's all fine. So you can load that directly from Excel, but I've got it in the database as well to show you some more, to show you the impact on the query folding as well. So if I load that in, Oh no, that's. Jump back onto this one. So if I load that target data in, again we're on import mode. So now we have targets, month, platform, target. I'm just going to create a new measure again for target total. And again, I'm just going to create a year-to-date version of that as well. Year-to-date. So because we have two tables here, one for sales, one for targets, we just need to make sure that the relationship's defined. You can see we've got a flat line like that. That is a strong indication the target, there's no relationship. So we'll jump back on here, and it's called month in this extract, and we'll join it back onto date. So now we can see the actual value against the target value. Obviously the target's monthly, so we're seeing kind of steps. So on the first of every month, the target jumps up. This isn't great for in-month reporting, so I'm just going to show you quickly how to change this so that you'll have a sort of a straight line representing the target. So I'm going to do that in Power Query. So here's my target data. At the moment, these targets are monthly. So to get a daily version of this, we need to know, well, first of all, we need to know how many days are in the month. So there are built-in functions in Power Query. So if you click on the month, add column, and under the date option here, there are loads of really fancy functions that allow you to get extra columns. One of them is the days in the month. So I'll do that, and then so now I know obviously in January there's 31, February this year there were 29. We're just going to create a new column, which is the daily target. And dead simple, we're just going to do what is the monthly target divided by the days in the month. So this now represents the target for each day within the month. What we need to do now is to change the grain of this table though, so we have a 1 row per day. So far, everything we've done is use the interface within Power Query, but you can go into the advanced editor and it shows you the M code that represents. There are much more features within Power Query than what is represented here, or in the interface rather. So I'm going to add a line in. And this is adding an extra column in using the custom function list.dates. So there is the documentation out there for Power Query. And if you go to Microsoft's website, it says list.dates, and this says here it returns a list of dates of the size count, the second parameter, starting at the start, and it has a step. Come on, just minimize that then. So in my example here, I've taken the start of the month and I'm having it create an item for every day in the month, and the duration, this is a duration data type which represents a daily increment. Just need to tell it to use this column, and so now we have an extra column here, which is a list, which shows us every single day in the month. If you click on it, you can see here all different options. It's showing the top 20. So what you can do quite easily is click on this button, click on expand to new rows. And now the data grain has changed from one that is monthly to one that is daily. So now we don't need a load of these other columns. So we can get rid of the month, we can get rid of the monthly target, and get rid of the days in the month. We can reorganize these. So this is now the date. So the the daily target. This is just now the actual target. And we can sort out the data types. Cool, so now this table we're loading into Power BI is much bigger, but it should allow better reporting. So if we load it in, and again, you can see it's gone like this. I imagine the relationship's broken because I've changed the column name, which is indeed what's happened. So we'll join date onto date. Oh, many to many. That's because it's the wrong table. Dates onto date. So now when we jump back into the report, we have our nice year-to-date target line against the actual. Then, as I mentioned, there is another property on these tables to do with the platform. So we've got a website channel and we have an app channel. At the moment, we can't slice by that because there isn't a common table to filter that. So I'm just going to show you quickly how to create that. We can do that by jumping back into Power Query. And I'm just going to reload those two tables. The aim here is to get the distinct values of both of the platform from both the tables. It's important to bring both in because potentially they could be different. So in this instance, I'm going to just click on platform and group it by the platform. Because we're grouping, it has to have some sort of aggregation. So we're just going to tell it to count the rows. And then we can hide this column. So this is the unique list of platforms in the sales table. Another way to achieve that would be to just remove the extra columns and then tell it to remove duplicates. So both of these have the unique list of platforms, but you achieve it in different ways. And if you view the query that's running against the server, you'll see this one's doing a select distinct, whereas the sales one will be actually applying the grouping. I think when it hits SQL Server's sort of query analyzer, these will amount to the same thing. But it's important to remember that the steps you go through to achieve a result can have an impact on the underlying database. So the final thing we need to do is just stick these two tables together, and there is an option for append queries. So we're just going to append it as new, and that will add the two tables together. So we want the target and the sales. Because it's added them together, it doesn't do a distinct sort of union, as we call it in SQL. It just adds two tables together, so we do need to apply the remove duplicates on this as well. So now we have our platform table, and we can call it as that. These ones that we use to generate the unique lists can be hidden, so you can turn off include in report refresh, and you can turn off enable load. So these won't be exposed to the underlying data. These won't be exposed into Power BI, so you'll have a nice clean data model. So if I load that platform table in now, I would imagine the relationships have been auto-detected. They have. So because the column names are the same, it's realised that the platform is related to both the sales and the target table. So inside Power BI, we can drag that in as a slicer, and then we can switch between the website and the app. So now it's easy to see that the website is underperforming against the target, and the app is overperforming against the target. I'm just going to remove this flat line here. So on target cumulative, you can just add a quick filter on, so you can say if the max of the date that we're referring to is smaller than today, then we will show the results. Otherwise, we're not going to show anything. But I did it on the target then, apologies. So I'll just cut that out. And I'll go and do it on the revenue one. And there we go. It's just truncated the line, so it's not showing any values that are in the future. So that in a nutshell is how to get your data from both revenue and target data and to compare it against each other. When you have it in this state, there are then many options you can sort of go forward and enhance your reporting. So I'm just going to jump to one I made earlier. One thing you can now do is add a trend line. Now, whilst it is possible to use the trend feature within the chart object, you can go on the trend line here. If you were to add a trend line, you don't get to see the values, it just plots it on the table. So if you add in a measure for the trend line, you can then see, and it will forecast where you're going to be at year end. And I've clicked on that, there we go. The formula I used for that was just something I Googled. You can go on, if you Google trendline DAX, this just creates a line of best fit, and you give it the measure that you want it and the calendar date, and it will just plot a line of best fit against that. The good thing about that is then it is responsive against the other slices. So if you click on the app again, you can see that the app is up and it's way ahead of target, and then the website is obviously underperforming. Another feature to this dashboard that I've added in is an option to allow you to choose aggregation. So at the moment this is website revenue versus target year to date, but it could be that you're interested in the daily. So I've created a slicer that allows you to switch between those two on the report. And again, this is responsive, so you can see the actuals for the app are above generally the target and the website's underneath, but then in aggregate, they're kind of in line. To achieve this functionality, the way I usually do it is I have a table that isn't related to anything else, one that I've manually entered, and in this case I've called it aggregation. I entered it in by just clicking on the enter data option, which is here, and this just allows you to type in values, and I typed in daily and year to date, and the measure I show in here interrogates that slicer. So the measure I'm showing on this chart is target. And if you look at the measure there, it's first of all checking if it has one value, which you can enforce by making it a select one option on the slicer. And then if the aggregation is daily, it shows the daily one, otherwise it shows the cumulative. So that means you don't have to have lots of different measures on this chart. And I did something similar for the title here. So I just asked it, what is the status of the aggregation? Is it daily, year to date? And also, what is the status of the platform slicer? And then I just stitched that together to create a title. And again, once you have the revenue and target values in place, you can then start calculating variances. So the year-to-date variance, percentage variance, and then I've also picked up the projection for the year end. So based on that line of best fit, at year end we're going to be £13,000 up, which is 1.7% against target. These are responsive to the slicers, so you can see that the website's going to be much down, but the app is going to be above. That kind of covers everything I was going to mention as part of my talk. I'm just going to check if there's any Q&As on here.
Thanks, Lewis. That was great. Yes, we have got a couple of questions. So some around the sort of native query around the union. So can we see the native query for the union done on the platform table? And another question around it, why is it that you had to modify the platform for both data sets?
Okay, so I'll jump back into here. So the native query for this table, it probably won't give it me. Oh, let's see. So I didn't realise it even did this. So yes, it has actually unioned the two bits together. So that was actually quite clever of it. In my experience, SQL Server sources are quite good at pushing as much as possible down via native query. Or other database technologies such as Redshift aren't as good, but they still do some form of push down. And sorry, Sheb, what was the other question?
The other question was around, they were both around the native query actually, so that's fine. And that's it.
Okay, and there's a question from Alex saying why not use the date from the sales table on there. I can see. So the reason we create a common table to pick the date from, a calendar table, is if you have multiple tables and metrics you want to chart, and if they're not all on the same table, then you need a dates table that's common to everything in order for the data to line up. That's
right, and additionally, a lot of the time intelligence functions do require a date table or a table that has a unique list of all the different dates.
Indeed, yeah.
And so when you have a date table separate to any other tables, it allows you to do the year-to-date values, the previous month, the previous year, same period last year, etc. Allows you to use all those time intelligence features as well. Yeah. And I think if I'm understanding the gist of one of the other questions, the reason I get the unique list of platforms from both the sales and the target tables is that although in this instance they just represent app and website on both, new channels could be introduced perhaps that we don't have targets for, or it might not remain the same over time. So if you do go and get the unique list of platforms, then if something does change in the environment, then they'll automatically show up in the report. Great, that's excellent. So there's been quite a few questions around sharing and publishing the reports and dashboards. We will make these available to you following the call. Look out for the links and the material afterwards. We'll send that across to you if you're registered with us. Okay. Yes, I can certainly share this Power BI file as some people have requested. Yeah, brilliant. Okay, well, thank you very much, Lewis. Appreciate that. So we're going to move over quite quickly to my session now. So if you just bear with me a second, I can share my screen and get this going for us. Okay, so hopefully we can see on my screen. So what I'm going to be doing today is doing just a quick bit of data modeling with Power BI. A lot of people that I've worked with in the past, they've imported or embedded flat files into reports and asked, well, how can I turn this into a proper model? Is this the best way to use you know, the Power BI you know, application? Now the answer is that the Power BI is the Power BI, a Star Schema is sort of the most efficient way to model your data within Power BI. When you have a flat file, there are other sort of formulas and DAX queries that you can do that sometimes wouldn't give you the right answers. But creating a Star Schema is your most efficient way to move forward with a Power BI report. And for those that don't sort of know what a Star Schema is, it is a mature sort of modelling approach widely used by a lot of relational databases and data warehouses. Dimension tables are business entities or things you model, products, people, places, and even sort of the date table as well. And fact tables are more a sort of store for your employee keys, your values, your dates, and other sort of numeric attributes that you have in there. There are things like a Snowflake schema. Now, as you can see from the first example there, we can have such things like categories and then subcategories and then products, and we can create a separate table for each of those, and this all comes under sort of the data normalization and normalizing your databases. And sometimes people, tend to go down to a really sort of low normal form. A normal form being that you sort of create a simple table with an ID column and link that to a table with a one-to-many relationship to another category, and then a subcategory, and then the product. The Snowflake schema it can be used in some situations, but generally, the disadvantages are that Power BI loads a lot more tables, which is less efficient for storage and performance perspectives. There's longer relationships, filter propagation chains, etc. The fields pane represent a lot more tables to report authors. It's less intuitive for users, and the user experience is affected as well. So generally, the Star Schema is the best way to move forward with a Power BI report. Now, in this example, what we're going to do is take a flat file from a simple source, a text file, and then we're going to create a Star Schema from that and apply all the different dimension IDs, etc., and create the Star Schema relationship in the data modeling experience as well. Okay. I'll move over to Power BI. Now, I've already loaded in a simple data set. So this source is a simple CSV value here that I've loaded, and these are the columns that we have in it. So we've got line IDs, order IDs, date. We've got two dates here: ship date, a ship mode. We've got the category, subcategory, country, region, state, postcode, customer name, profit, and then some values as well. Okay, so the idea is that we're going to try and keep all the numeric values in here, and then remove all the non-numeric values into dimensions. Okay, so I guess how do you sort of go about doing that? Okay, so there's a couple of ways we can start to do that. The first thing is, let's take the customer name. Okay, so we want to create a customer dimension from the customer name. First thing we can do, we can right click on there and we can add as new query. Okay, that adds it to a new query. We can then put that into a table like that. We can then remove the duplicate, so we got a nice distinct list of our customers. Then we go to add column, and then we can add an index column from 1. Okay, I'm going to call this customer ID. Call this customer name. Okay, then I'm going to rename this to dim customer. Okay, I'm going to go back to my sales table, and then I'm going to merge a query. So I'm going to merge a query, and I'm going to say, okay, well, I've got my customer name, join that onto my customer dimension, and it should give me 9,000 odd connections, which it does. Brings in my my table, and then all I'm going to do is select the customer ID from there and click OK. So now that's brought through the customer ID from my dim customer table, and all these sort of, you can see there's Rosina Hoffman who's ordered a number of different times. We've now got the same number, she's got an ID there, so we can now get rid of this customer name. Okay, so then we can go through and think, right, well, okay, what else have we got in here that we can change? So we can see that we've got a category, subcategory, and we've also got a product name. So we can create a separate hierarchy for each of those, but then that's going down the route of really normalizing it to a form where we don't really want to go to, and it's not going to be efficient for reporting. So what we're going to do is create a hierarchy or a product table that has a product name, category, and subcategory as well. So the other way we can do it, so what we did last time, we right-clicked and we added a new query, and you can only do that as a single when you select a single column. Excuse me. This time we're going to right-click the actual data set, and we're going to take a copy of that. So we're going to duplicate that. going to go back up to this merge queries here. We don't need it, so we can delete from there onwards. So we've just got our data set. Then from here, we're going to take a category, our subcategory, and we're going to take our product name. Okay, then we're going to right click and remove all of the rows. So now again, we've only got product name, category and subcategory. From here, we're going to remove the duplicates because we only want one of each. Okay, now here at this point, again, we're going to add an index column from 1. And that's going to go in there. And we're going to call this product ID. Move that to the beginning. Then rename this to dim product. Go back to our sales data. Now the bottom level value of that data set is the product name, so that's going to be the distinct connection that we're going to use to join onto it. So if we come back to our sales data set, merge queries, we're then going to merge on the product name, get this product name, got the same number of matches, and then we're going to expand that, and we're just going to bring through the product ID. Okay, so now because we've got the product ID, we can get rid of the product name, category, subcategory. Remove that. Okay, so now you can see that we're starting to build up all the numeric values, we're bringing in the IDs, and we're removing all the text values there as well. Product name as well. Okay. So the next main one we can see is that we've got a location dimension possibility here. Yep. So we can do the same thing from here, and I see the bottom level is potentially going to be our postcode there. Okay. So again, we're going to right click and we're going to duplicate that. Get rid of everything from here. So we've just promoted headers. And then we're going to keep our country, region, state, postal code, and remove all the other columns. From here, again, we're going to remove our duplicates, which then gives our unique values. And then we're going to add an index column in here. I'm going to call this location ID. I'm going to put that at the beginning. We're going to go back to our data set, and then we're going to join this back on to our dimension using postal code. I haven't renamed the other one. I think it was that. Yep. Select columns of the same type. Okay, so let's go back here. So postal code is a text value there. We go back here, postal code is a numeric value here. So Power BI does like to change types. So I'm going to change this back to a text because US postal codes sometimes have a leading 0, which Power BI sometimes thinks is a number, well, is a number, but represents it as an integer rather than a text value. So keeping it as a text value keeps any sort of leading zeros that may be on there. Location, and let's try the connection again. So this time we'll merge queries again. Postal code, location, 9,000 connections, which is great. And we're going to select our location ID from there and bring that through. Okay, so we can get rid of our postal code, region, state, and country. So remove all those columns from there. Okay, so we have our order date and we've got our ship date. Now, what would be good is if we could bring in a date table. So one of the ways that I like to create a date table is to do a search on create a date table in seconds. And there's a great YouTube channel, the BI Whiz Kid, which is great. And on here, we can create a date table by simply copying this code that we've got here. Okay, so what this does is open up a function. It tells you in the video how to apply it, and it's literally is creating a date table in seconds. So you take a copy of this code, we go back to our query, and we're going to create a new blank query. We're going to go into the advanced editor, paste our stuff in there, and then that gives us a nice little interface to say, okay, well, when do you want your date to start? So we can say, okay, I want my date to start first, because I know it's 2015, I'm going to say 15, and then I want it to end on the 1st of the 1st, 2019. Okay, and then I click invoke. Now that gives me the date, the year, the quarter, the month, and then it even goes into the financial year, gives me financial information, financial month, quarters, days of month, month calendar, etc., all the different aspects that you would like for a date table. It gives you there, even the ISO weeks and periods as well that you've got there you can use. Okay, so first thing I'm going to do, I'm going to change this to dim date, and then I'm going to make sure that all these values here, so the year, the quarter, the month, financial year, financial month, financial quarter, any values that are numeric, you can select them all, and if you go to transform, you can then change all those data types in one go. I'm going to change that to a whole number. Okay, so whereas if you select sort of multiple options there, you can't change the type here, but you can change the type for multiple columns if you select the option from the transform at the top there. Okay, so now we've got a connection for our date table here. At the moment we've got different formats there, so we change this to a date. We'll change this to a date, and if we really wanted to, we could connect into the date table and we could get our date integers from there as well. But I'm happy just to have that date in there. Another one we could do is ship mode. So ship mode we could add in as a new column. So again, we could right click and we can duplicate sales. Go to our data, delete until end. Okay, get our ship mode, remove other columns. We'll remove any duplicates from here, which just gives us our simple list, and then we'll add in a column that's just an index value there like that. ID. And we'll rename this to dim ship mode. Okay, go back to our data set and we will merge our queries here with the ship mode. Then we'll expand this, get our ship ID, click OK, and then we can go ahead and remove our ship mode column. Now you can see that our fact table is now full of facts. So we call it a fact sales. But as you can see, we've got rid of all the sort of text values, and all we're left with is our numeric values here. Yeah, we have got a order ID. Now I think the ideal would be to have an order header, order header table. So we could pull that out and put that into a separate table as well, and that would be our order header table with our order lines here. Okay, but for the time being, we're just going to leave that. I think we're happy with fact sales. We've got a dimension customers, dimension product, dimension location, ship mode, and date. Okay, so we can go through and apply this. Okay, and because we've used the same data sources, we've used you know, it's pulling the column names across from the dimension tables to the fact tables. Hopefully, when we go into our model here on the left hand side, you know, it's already created our star schema for us there. Yeah, The other thing that we're going to join on here is the order date to the date, which is there. And we're also going to do the ship date to the date as well as our secondary connection for all those additional time intelligence functions that we need. So there you go. So that's from a flat file. We've now created a star schema, which now going forward is going to be a lot more efficient for Power BI when you publish it online and it's in memory and it's filtering and it's slicing and dicing from all the other different sources. Go back to this page here. So this is just a basic one, which again, I've done the same thing here. If we go and look at the model, it's the same thing that I did earlier, almost like a Blue Peter. But if we filter, we can see how instant and how quick that is as well, and how quickly that sort of moves around. You know, it really does improve the filter experience. And with this only being sort of a small data set, you really will notice the difference when you have millions and millions of rows of data. When you start filtering and you start highlighting, you will see how instantaneous it is and how much it does improve the performance of your reports. So although a flat file has all the data in there, you do need to split it out to make it more efficient for Power BI and for the user experience as well. And just here, I've created a couple of measures doing the growth chart, which I've put in here, just showing the previous year sales as well. So looking at Q4 2017, I can see the sales that were done in that year, the profit, the sales for the previous year, and then the growth from that year as well. I can instantly sort of see that, and I can order it and see exactly which sort of categories of products sold the best and sold the most compared to the previous year as well. So we can do a lot of analysis on there and how instant that was to update all the values on there as well. Okay, so that's how we can take a simple flat file, apply a number of transformations to it. We can then split them out, remove columns, reduce the size. Our aim is to really reduce the width of the fact table. So we're removing all the different text values, we're putting them into their own individual dimension, and we've got a distinct list of that. So that's reducing that storage as well, which allows sort of Power BI to pick up that index and then go and get that data and filter it more efficiently. And you have to remember that although the file size might be slightly bigger, once Power BI pulls that model into memory, it's using that model that you've created that it pulls into memory and uses that to filter and do all your sort of analysis online. So if that model's efficient, if that model's a star schema, you will get the best experience from that. Okay. So thank you for that. That's the end of that. So we've got the last 10 minutes, so a few more minutes left for any questions. I'm just going to pop up the questions for, or if Lewis, if you can grab any questions.
One thing I was going to ask is, in my demonstration, I created the date table through a DAX set of code, which I pulled online off the website, and you created yours similarly, but through Power Query. Have you any comments about which way is better or worse?
Okay, well, I guess doing it in DAX, you're already doing it in the front end of Power BI. If the way I did it in Power Query, so I applied the changes, I created the date table in the background and then pull that through, and then there's no calculations now going on in the DAX side or in the Power BI front end of things. Whereas, I believe the one that you created is in the DAX side. There's calculations going on, as you publish it. So if that model was published, the calculations to create each of those sort of columns are being done on the fly as well. So just to take away the burden of that performance away from the sort of front end of Power BI, I've used it in Power Query and pulled it into the back.
Yeah, I would agree with your sentiment there, Sheb. The DAX tables are generated dynamically, so there is an extra sort of processing time that could have a performance impact on the dashboard. I have to say I've used that quite a few times. I've never experienced any problems with it.
Yeah.
But I would always prefer to have it in SQL Server. If not, your method through Power Query, I wasn't aware of that. It does look good, and I'll probably adopt that option as well. You'll know as well that if it's in Power Query, you'll get all the benefits of the compression and all sort of the sorting as well. That's inherent to Power BI. So I would definitely prefer your method over mine in that instance.
Yeah, great stuff. Okay. Was there anything else before I switch over?
Sheb, we've still got some more questions on the Q&A.
Okay, yeah, that's fine.
Have you seen them on the new Q&A tab to go through?
Yeah, I'll have a look in a second if you just bear with me.
No worries.
Alex. Okay, let's have a look. So I'm just going through the questions at the moment. So is it more efficient to use the index column to create the ID column and merge back to the fact table than just using the customer name to relate the tables? It is more efficient. Now, if you think about what we did was we connected through we did all that connection in the Power Query side of things. Now that gets hidden once it's published to Power BI. That refresh or that information, that process only takes place when you refresh it. Once it's refreshed, it pulls it through to the model. Now the model is now using a single index rather than the whole sort of text value name. So it is more efficient to use the ID column because Power BI uses that as an index to then connect to your model. If you think about using text name or the customer name, for example, it then has to sort of go through every customer name, you know, and iterate through each of those and sort of do the calculation that it needs to do through a text value rather than just a single integer or index value. So yes, it is more efficient to use an index column. Yeah, another question around the improving efficiency. Yes, it does improve the efficiency if you do use an index column for that. If I'm using monthly sales data refresh, will I be able to follow this structure using the dim tables to get my reports to update automatically? Yes, you will. Again, all the processes that you put in place in the background, you know, the way that we've done it today is to ensure that when you do go forward or move forward with the report, if changes are happening in the background, they will automatically filter through. There was the merge query that Lewis did where he sort of took the distinct values from two different tables and then merged them together into one. Any new data coming into those tables will then, you know, come through to that distinct table at the end as well. Let's have a look at some others. Why did you use duplicate instead of reference when you create the dim tables? Reference. Is there a reference option? Not sure which reference.
Yeah, you can reference the outputs of another Power Query and kind of use that as a starting point. I guess if you were to do that, it would apply all the transformations you had on the fact table before you then remove the columns and distinct it. So I'm guessing the reason you duplicated it was just to get the source there very quickly, and then you're not doing any unnecessary calculations, are you?
That's right. That's exactly right. Yeah. So what I did was to duplicate the connection. I got rid of all the steps, you know, from the top downwards. So I've just got a simple connection, and then I just applied that transformation or that value to that single column, and that's the reason for that. I find merges in Query Editor can sometimes be very time consuming. If you do this data modeling approach, do you find your data refreshes taking a lot longer? But it depends how much data you have. You know, essentially we are putting a bit more time into to create this model, but what you have to remember is that this is for the user experience. So we're creating a better model in the background so that the users who use the report have a better experience on the front end and have a, you know, a more efficient model to use, because it's better that the delay takes place in the background than on, you know, in the front end, because that's where you get the complaints and you get people saying this is too slow, this is too slow. If you take care of that in the background and have it done you know, in a refresh that takes place at 5 AM in the morning, you know, nobody sort of notices that. So essentially, that's what I find with that.
And then just to jump on that, Sheb, I've gone down the route you've just demonstrated and ended up with quite complex Power queries in a series of tables that refer to each other. It can end up slowing down sort of the refresh time on Power BI desktop a little bit. As Sheb says, it's a worthwhile sort of endeavour anyway because the report's quicker. But once that Power BI desktop file is published up onto the service, I find that the service is really, really quick at handling complex Power queries and M code. So I wouldn't be too concerned about that, even if it is a bit slow locally. I've had reports that take minutes because of the complexity of Power query, but then when it's on the service, it's seconds. So I do think this service is really geared up to processing Power query. Yeah.
Okay. Another question is, how many dimension tables can you add to the fact tables in a Star Schema? I don't think there is a limit really. You know, what you have to remember is that if your fact table is getting too wide, you know, the idea is we're trying to sort of reduce it. And if it is getting too wide, just think about, you know, are you reporting the right values? Can you split that out into another fact table and have a separate fact table for that and reduce the number of columns in there? So there isn't, I don't think there is a limit. But I guess if you keep it, you know, constrained, keep it controlled, you know, depending on what the level of normality, I talked about the normalization and the sort of level that you go down to, you know, just be sensible that, you know, keep your, you know, your dimensions grouped. So for example, the products and the product categories and the subcategories, have them in a single dimension. Rather than having a dimension for category, a dimension for subcategory, and then a dimension for product. You know, there's 3 different connections there you can just put into one. So just think about that when you're creating that. Okay. Again, the file, about sharing the file, we can share the file and we can share that with you guys. So not to worry, I'll share them as it is. So you can go back and have a look at what transformations were applied and try and work yourselves through that. Now, if your flat file already has unique IDs, would you get the same benefits by splitting the ID into a separate table and then getting rid of the name of the original flat file? So if your flat file already has unique IDs, again, sometimes people do have business keys, so, you know, customer IDs maybe CS/12345, etc. Again, that's the same as any other text value. That Power BI still has to iterate through that textual value and try and filter that out. So if you can create an additional numeric index value, that will be more efficient. But keep that business key in there for that reference, you know, to your own company, your own organisation, so that you can relate back to your source systems with that as well. Okay, is this running direct query mode or employee mode? What are the performance considerations? Okay, that's a good question. So a lot of the modelling that is taking place here, so this is direct query. Sorry, this was the import mode. So the import mode gives you the option to do the modelling on the Power BI side. If you had a direct query, you wouldn't get the option to do that modelling. The modelling would have to take place back in either the SQL connection or the Cube or the SSAS connection that you've got. And again, you would apply the same rules at that point as well. So make sure your model is a Star Schema model that it can pick up and connect through. Because again, if you're working on the fly and you've got a direct connection, you want those SQL queries or those analysis service queries to be efficient, and you want them to get the data as quick as possible without having to iterate through all the different rows and columns that are in there. Okay. Okay, I think that's come to the end of the questions. Thank you everyone that's joined. Really appreciate you taking the time off to come to this event. There'll be another one next week. Ben will be with us next week with a great session. We'll let you know in the next couple of days what those sessions will be. But if you have any questions in the meantime, you've got our contact details. Alex is there. You've got our LinkedIn profile pages. So get in touch and get involved, get social. And get registered. Okay. Thank you very much.
Yeah, big thank you to Sheb and Lewis. We'll see you same time next week. If you have any questions, feel free to send it through the meetup. We'll share the PBIX files and all slides that are requested, and we'll endeavour to get back to you as soon as possible. But as Sheb said, we'll be announcing the topics for next Wednesday's talk with Ben, Lewis and Sheb. Enjoy the rest of the week and take care.
Great stuff. Thank you, everyone. Take care. Bye.
Bye.